Okay, let's take a peek into cross-site scripting. Now keep in mind, again, with the cross-site scripting, the attacker sends text-based attack scripts that exploit the interpreter in the browser. This is going to be in the client browser, Internet Explorer, Firefox, Chrome, whatever it is that you're using there. Okay, almost any source of data can be an attack vector, including internal sources such as the data from the database itself. Now, I wanted to give you guys maybe a little sample of what something that may look like. So when we're looking at a cross-site scripting type of attack, a lot of times what you're going to see is something that has maybe something like this in here, right? You have the script, right? And whatever, you have your document, whatever location, and so forth along with that. And then it references generally a whatever, website that it's pointing to. So in this case, it might be I don't know, whatever the attacker's website is, right? And so forth, and then maybe putting it into a CGI bin, which we mentioned before. CGI bin has to do with Perl a lot of times, which again, with Perl and CGI, it allows us to actually execute executables and so forth on the server from the client side. It's a pretty sweet deal, actually, when we have things like that going on and such. So. But again, we have the ability to do something like this, and again, it's kind of what something like this would look like when you're looking into that cross-site scripting document, something like this. And of course, it ends it with a script as well. So that's kind of what it would look like, sort of more or less. So anytime you see anything that has to do with script within, most likely it's going to be a cross-site scripting type scenario. Now there's basically two types of cross-site scripting and so forth. We have what's called the non-persistent or reflected cross-site scripting vulnerability, which is the most common type that's out there. And they basically show up when the data provided by the web client, most likely like in an HTTP query parameter or HTML form submissions even, is used immediately by server-side scripts to parse and display a page of the results for and to that user without properly sanitizing the request. Now, because of your HTML documents, they basically have a flat serial structure that mixes control statements, formatting, and actual content and so forth. Any non-validated user-supplied data included in the resulting page without proper HTML encoding may lead to markup ejection. And again, it allows us to basically do that. Now, a classic example here would be a search engine. Yes, a search engine. So if one of the searches for the string, right, the search string will then typically be redisplayed verbatim on the results page to indicate what it was searched for. Now, if this response is not properly escaped or reject the HTML control characters, a cross-site scripting flaw will generally ensue here. Now, a reflected attack is typically delivered via email or via a neutral website. The bait generally is going to be an innocent-looking URL, which you've probably seen in some of your emails, pointing to a trusted site but containing cross-site scripting vector. If the trusted site is vulnerable to the vector, clicking on the link could cause the browser then execute the injected script. Now we also have what's called the persistent or the stored cross-site scripting. And it basically is a more powerful, devastating variant of the cross-site scripting flaw. It occurs when the data provided by the attacker is actually saved on the server and then permanently displayed on normal pages returned to other users in the course of a regular browsing without proper HTML escaping. Classic example of this was online message boards, where you're allowed to actually post HTML formatted messages for other users to read. Now keep in mind here with persistent cross-site scripting, they can be more significant than other types because an attacker's malicious script is rendered automatically without the need to individually target victims or lure them into a third-party website. Particularly in the case of social networking sites, the code would be further be designed to self-propagate across accounts, creating a client-side worm. The methods of injection can vary a great deal. In some cases, the attacker may not even need to directly interact with the web functionality itself to exploit such a hole. Any data received by the web application, whether it be via email, system logs, instant messaging, or whatnot, can also be controlled by the attacker then also become the injecting vector as well. So imagine you're going through your instant messaging and then having something like this happen. Right? Could definitely be a possibility. So here again, looking at the script scenarios, mainly what you're going to be looking for when it comes to these cross-site scripting type of scenarios when it comes down to it. Anyway, the other thing is obviously here with the cross-site scripting, it occurs every time raw data from an attacker is sent to an innocent user. All right, so here we see actually the historic cross-site scripting illustrated. So again, as we mentioned, this is one of the more dangerous type. The attacker here sets the trap, like something like update my profile. The application with the stored cross-site scripting vulnerability, of course, is there. We have the victim views the page, sees the attacker's profile, and the script silently in the background sends the attacker's victim's session cookie information, which can then be used to, of course, take over sessions and so forth as well. That's happening. Again, very dangerous. We kind of went through the explanation here just a few moments ago. Just know that it is the more dangerous type of the two, the non-reflected versus the reflected type that we have. All right, and here is the reflected cross-site scripting illustrated. So here, basically, we have, again, search field input, which is often reflected back to the user, again, coming from the browser. And of course, here the site reflects the script back to the user where it executes and displays the session cookie in a pop-up in this particular case. Now keep in mind, this is the more common one of the two, but also is all going to be very browser independent, so or dependent, I should say. So this will happen with any version. So you have Firefox, Chrome, IE, whatever else that it might be using. This has to do, of course, with the browser. Now keep in mind too that when it comes to JavaScript, for instance, a lot of times your JavaScript will execute without you even notifying you and so forth. That's why we have additional add-ons like NoScript, for instance, that will allow you to actually check any scripts that are going on and then give you the permission or the power to either run the script or not run the script and so forth. The impact obviously is going to hopefully be obvious. Looking at stealing user sessions for complete account takeover, stealing data on web pages possibly viewed by the victim, defacing pages viewed by the victim, monitoring pages viewed by the victim or even scanning the victim's intranet. So when it comes to the ejection flaws, it basically means that tricking an application into including unintended commands in the data sent to the interpreter. The interpreter then takes the strings and interprets them as commands, such as SQL, like your OS shell, LDAP, XPath, and so forth. Now, SQL injection is also one of those that are still quite common. We'll have another section on this strictly on SQL injection, which we'll get to here shortly. And keep in mind that many applications are still going to be vulnerable to these types of things. Now, keep in mind when it comes to, let's say, cross-site scripting, for instance, we can actually initiate that and see if a particular server is vulnerable to those types of attacks by just using a single quote. All right, so when it comes to unvalidated input here, keep in mind one of the things we need to look into is architectural issues, right? When it comes down to it, solving any single validation problem is generally going to be pretty straightforward and simple. However, creating an architecture that prevents problems is generally going to be a lot harder. Realistically, when you come into an organization, you're already running into existing problems that you have to fix. So the likelihood of you actually doing things from scratch are not likely. But that's why we have these issues. So when it comes down to the architecture side of things, keep in mind you're always running into something that's already been out there, already been out and growing for the last decades and whatnot, and you're having to then go back and try to fix those problems, which again may be more trouble than it's worth, at least to some companies. Create a library for validation and encoding, which make it the only way for developers to access a raw input, and also use positive or whitelist validation even. And the leading indicator of attacks in progress, here virtually all applications let attackers attack forever without even detecting that they're under attack. We also had attacks specifically against IIS. At one point in time, IIS was very high up on the list of web servers that were out there, even though Apache servers are actually taking over. But needless to say, the primary problem was insufficient bounds checking in the URL, allowing hackers to insert malicious code and so forth. And some of the examples, these are old attacks like your $$ data vulnerability, your show code ASP vulnerability, piggybacking vulnerability, privilege command execution, and the popular buffer overflow exploits using the IIS-hack.exe tools and so forth. Again, a lot of these are from old versions of IIS, like IIS 4 and IIS 5, but you won't be able to use any of these types of attacks anymore, and for practice questions and so forth, you won't be able to, there won't be any questions regarding these specific attacks, but again, proof of concept that yes, web servers are a target regardless of what version they are, and we can of course always find something out there that will assist us in the process of gaining somehow control over that web server using a tool of some sort. Now when it comes down to doing things with Unicode, for instance, here keep in mind the ASCII characters for the dots are replaced with hexadecimal equivalents. And here, for instance, the %2e would be equivalent to that. So your ASCII characters for the slashes are, for instance, replaced with the Unicode equivalent of %C0, %AF. Unicode 2.0 now also comes into play, which allows multiple encoding possibilities for each character. So for the slash, it could be 2F, it could be C0AF, it could be E080AF, and so on. Right? Overlong Unicode is generally not malformed, but not allowed by correct Unicode encoders and decoders. So what someone can do maliciously, it can be used to bypass filters that generally only will check for short Unicode and such. So again, there's lots of different ways to go about it, and how I normally would refer to this too is as a specialty. So if you're doing something out there that will have to deal with the web servers and the web application side of things, then that definitely could be something that we could utilize out there in the field and so forth. So knowing Unicode will definitely assist in some of that as well, because it does do actually a pretty good job on giving us information that we could possibly use to bypass, again, those web servers, depending on what they're checking for and so forth. So with that in mind too, what we could do then is we could do things like IIS directory traversal, also known just commonly as directory traversal attacks. Vulnerability results because of a canonicalization error affecting the CGI scripts and ISAPI extensions, like your ASP is generally going to be known as the ISAPI map file type, best known as anyhow. Canonicalization is the process by which various equivalent forms of a name can be resolved to a single standard name. So as we mentioned in the previous slide, right, we can have the %C0, %AF, and so forth, which are basically overlong representation for the slash and //. Thus, by feeding the HTTP requests like following the IIS, arbitrary commands can also be executed on the server. How cool is that? Right? Of course, you'd have to know in the default locations of these things as well. Now here we're going to an WinNT System32, which means that it's most likely a NT4 server or a Windows 2000 server. But you can see here we're using the get scripts. We're popping in our %C0, %AF, right? We're putting in the WinNT System32 command.exe, and then we're doing the question mark, and then remember after the question mark we can actually then put in our parameters. So in this case here we're doing C plus dir equals C colon, and basically what we're doing is we're getting a directory listing from the C drive on our web browser. IIS logs, as I may have mentioned before, the IIS logs, as long as we know where the default location is, we can then go in and possibly manipulate that or even show it as long as we know where the path is. So the IIS logs, of course, all the visits and the log files, those log files are located in the system root /log files, which is generally going to be like your C Windows System32 log files in this case. All right, so be careful that you don't use proxies, then your IP will be logged, right? So the command lists, as you can see there, all that with the NT System32 command.exe, looking at the WinNT System32 log files, and then W3 SVC1 to actually get a hold of those log files. This allows us to then actually see what's in that directory and see what may possibly be logged. And we mentioned a tool, of course, that can assist us with when it comes to the auditing side and so forth, which was one called Audit Poll. I have some tools we can use to assist us with the whole process of finding web application vulnerabilities and so forth. And one here is called NStalker. And basically, we'll go out there and check for, in this case, over 18,000 HTTP security issues. Scanner writes scan results to a rich text format or PDF report. And it's often used by security companies for penetration testing and web system auditing. Again, just good FYI tool to know. Tends to do a really good job. Another is called NTO Spider. It's a completely automated assessment, has dynamically identifying and retrieval of all site content. It has a JavaScript dynamic content assessment, safe to scan production environments, identifies vulnerabilities and site exposures, as well as detailed remediation recommendation, which is always very nice. And HTML reports with flexible XML data is also available with this tool. And you can check it out at the www.ntobjectives.com site. Another great tool for this is to grab all of your website data and so forth is a website copier called httrack. And it does a really good job at allowing you to actually then view the website offline. Now there's some other tools out there like Proxy, for instance, which is Proxy used for assessing a web application vulnerability. It supports editing and viewing HTTP messages on the fly with spiders, client certificates, proxy chaining, filtering, and intelligent vulnerability scanning. And what we can do here is actually make modifications on the fly, as is mentioned here. So what we're doing is we're basically trapping information. So, for instance, if let's say here in this example that we see on the screenshot is we're purchasing something. So we click on the chart on the shopping cart, and then as it goes to check out, what you're doing is you're changing the price from what you've purchased from $10 to $1, and by the time you release it to continue on after the modified data, you will then actually be on the checkout with your $1 instead of your $10 or whatever the case may be there, right? So we do have the ability to do that. Now obviously this would be protected on the newer servers and so forth, so it's not going to be available for all web servers. Another tool that we can use as similar to the Proxy is called Burp Proxy. It's been around also for a long time. Also has the ability to trap the data before it gets sent out to the server. This also works with SSL, your secure socket layer, runs port 443. Now here, cookies. The cookies are a popular form of session management. They are often used to store important information such as username and account numbers, and they can also be used to store any data in all the fields that can be easily modified using a program like CookieSpy. Now there could be, of course, other information in here such as username and passwords that it could store, so keep that in mind as you're going out there doing that. Now with some of those, with some of that information there, since we're kind of talking about cookies and so forth, I wanted to mention again the use of session tokens and such. And basically what happened here is the ability to go out. Let's say we have our victim machine. Let's say we have our victim. And the victim is basically setting something out with a session ID of whatever it is. I'm just making it up kind of thing. Okay. And of course we then send that to our server for verification and so forth, right? So what someone can do, this could be an attacker. Let's say we have an attacker here. And the attacker, basically what they would do is they would sniff the traffic coming from the victim to the server. And what they can do is basically sniff that session ID, and from there get that to the server, whatever that session ID is that was used. And of course, again, looking at this information, we're able to grab this, let the attacker now be part of that. So now the attacker is using the session ID that the victim had, all because it was able to sniff that information over the network and so forth. And this is called session sniffing attack. And again, this could happen, of course, a lot of times when you're connecting to a web server and you are looking into the session information and so forth, which again could be stored in your cookies and so forth as well. So it's just a matter of gaining access to those resources and seeing what's going on and so forth. right? So another thing too, when it comes down to actually grabbing some of that data from that user, let's say you get an email and it basically has to do with here's a link and so forth to the site, and you didn't want to click on the link. What would be another way that you could possibly verify that the website link that is being sent to you that is authentic? And so forth. So some of the things there, of course, you can do is you can navigate to the site itself. However, if you've been DNS cache poisoned, right, and so forth, or if your host's file has been compromised, then when you go to the site, it may be redirecting to the attacker's site and so forth. So another thing you could do is you could actually go to like your Google search engine and just click on a link from there to kind of help go out there and verify the address, as in the website address and so forth along with that. Okay, so anyhow, other tools we can use. One is called Acunetix Web Scanner. This is probably the #1 tool out there for web application and so forth that you have to pay for. It checks for SQL injection as well as cross-site scripting. It has what's called the AcuSensor technology. Port scanning and network alerts will be enabled. Legal and regulatory requirements compliance is also part of it as well. So you just check some check boxes, say, hey, I want to see if this is PCI compliant, or I want to make sure this is SOX compliant or HIPAA or whatever the case, and it assists with that process, and of course with the report writing as well. It also has advanced penetration testing tools. It scans for Ajax and Web 2.0 web applications, tests password protected areas, and uses the also popular Google hacking database.